Welcome to lecture 5 on module 3 of ARM microcontroller and embedded systems. So in the previous lecture we discussed about communication interfaces, and in communication interfaces we discussed about onboard communication interfaces. So as I told, there are two categories in communication interfaces: onboard and onboard, which is internal, and then offboard, which is external communication interfaces. So we discussed about onboard communication interfaces, which are used for communication between the various chips, or you can say devices that are present on the same PCB, which are present on the same PCB, or which are present on the same SoC, which is system on chip. So we discussed about onboard communication interfaces, and all are wired communication interfaces only. So today we shall discuss about uh, off-board communication interfaces. Okay, off-board communication interface. We'll jump to that page. Yeah. So external communication interface. So the first one we'll discuss is RS-232C. Okay, and RS-485, which are both are very much similar in operation. Yeah, so what is RS-232? It's a standard. So it is a recommended standard number. RS recommended standard number. So the number is 232, and the version is C. You can say revision version is C from Electronic Industry Association. So it is a legacy full duplex. So it is full duplex means so both direction communication is possible simultaneously. That is, if there are two devices, device 1 and device 2, so device 1 can send the data to device 2, and device 2 can send the data to device 1 at the same time. So that is what is full duplex. So full duplex example is your mobile phone, wherein whenever two persons are talking, both the persons can speak simultaneously. Right? So it is full duplex wired. Again, it is wired asynchronous serial communication. So it is full duplex wired asynchronous serial communication. So again, it is serial 1 bit at a time. So since it is full duplex, there are dual channels for communication. Right? So next, RS-232, what it does, it extends the concept of UART. So basically, it is nothing but UART, or it extends the concept of universal asynchronous receive transmit signals for external data communication. So we discussed UART as a onboard communication interface, right? So now this onboard communication interface is being extended so that it can be used for external data communication. So what UART does is it is a standard TTL or Cmos logic. So you might have already been familiar with the Cmos logic, wherein so how will you represent a 1? So a 1 data bit 1 is represented using a logic high, and a 0 is represented using logic low. Okay, so logic high and logic low. So that is what is explained here. So that is what the UART follows, zeros and ones, how it represents using logic high and logic low. So now we might ask, what is logic high? See, suppose the operating voltage of that particular embedded system is 3.3 volts, then the logic high is usually represented as 3.3 volts only. So that is what logic high means. So if the operating voltage is 5 volts of that particular embedded system, then logic high corresponds to 5 volts. So that is how logic high varies. So logic low is obviously ground potential or 0. So this is what UART uses for bit transmission. So this is how it communicates bits to other devices. But the change in RS-232 is it uses EIA standards. What is EIA? You just saw here, Electronic Industry Association. That is what is EIA standard, Electronic Industry Association for bit transmission. So here, what is the change? So here a 0 is not represented by a ground potential, but it is represented with a voltage between +3 to +25 volts. So this is the difference. So logic 0 is represented between any voltage which is within this range, +3 to +25 volts, and logic 1 is represented with a voltage between -3 to -25 volts. So logic 1 is represented using a voltage between -3 to -25 volts. So that is what is EIA standard. And in EIA standard, logic 0 is known as space, okay, and logic 1 is known as mark. So this is the difference, you can say. So the you can say that RS-232 operates at a much higher voltage compared to UART. Fine. So this is necessary because it wants to extend the UART communication to external world. Right. So RS-232 define various handshaking and control signals for communication apart from transmit and receive signal for data communication. So what do you mean by various handshaking and control signals? See, handshaking is very important whenever you want to communicate with the other person, okay, or other device. For example, suppose so you call a particular person. So as soon as you call, so what you will ask him, so whether you are audible. Okay, so for that, what is the handshaking signal? You say hello, and the other person also says hello. So that means both the persons are able to hear each other. So that is what is a handshaking signal. So whenever you want to communicate, so you must be sure that the channel is established properly. So for channel establishment, handshaking is required. Okay. So along with that, so there are certain control signals. So what are the control signals? See, the control signals might be a start bit or a stop bit. Okay. So which indicates the start or stop of a communication. Communication. So that is what. So control signals. And control signals that we already studied till now is chip select signal, correct, which will select a chip to whom the processor wants to communicate, because there are many chips in the SoC. So you should not communicate with all the chips, but you should communicate only with the one chip which you want to communicate. Okay. Yeah. So in RS-232 there are two different types of connectors. So DB9 and DB25. So these are the two types of connectors. So what is DB9 means? It is a 9-pin connector, that's all. So that is why it is known as DB9. And DB25 obviously is 25-pin connector. So this is the diagram you can see. So to the left is the DB9 connector, which has only 9 pins. Okay, and DB25 it has so how many? 25 lines. So you might have seen these connectors. Okay, so such connector, this type of connector you might have seen for connecting printers and all. The old printers, not the new ones. New ones operate on USB these days, right? So you might have seen such diagrams. So now, so out of these 9 pins, what are the various functionalities? So you can see, so there is a TXD pin, there is a RXD pin. So for transmission, for reception. So what is the number? So 3, 2. So we are talking about DB9 connector. Okay, not DB25, only DB9 connector, 9-pin connector. So used for transmit serial data. So RxD is used for receiving the serial data. So RTS is request to send, which is pin number 7. CTS is clear to send. So DSR is data set ready. So it's ground, which is 5. So then DCD data carrier detect. DTR is data terminal ready, and RI is ring indicator. So we shall see what are the uses of these 9 pins, right? So out of 9 pins, some are self-explanatory. So we shall see about the remaining. So RS-232 is point-to-point communication. So this point-to-point means from one device to another device. Okay, and devices involved in RS-232 communication are called data terminal equipment and data communication equipment. So there are two types of equipment, DTE and DCE. Right? So usually, which the system which initiates, or the device which initiates the transmission is DTE. So if no data flow control is required, So only TXD and RSD signals and ground line are required for data transmission and reception. So the RxD pin of the DCE should be connected to the TXD pin of DT and vice versa. So this we saw in UART. So if you remember in UART, so I told the connections are cross coupled. That is, there are two devices which support UART. So what should happen? So the TXE pin of the device 1 should be connected to the RxD pin of the device 2, and the TXT pin of the device 2 should be connected to the RxD pin of the device 1. So that is cross couple connections. So same is holding true here also. Why? Because this is nothing but the extension of UART. So that is why here also it is true. So if added data flow control is required for serial transmissions, various control signals are appropriate. Okay, so which are mainly implemented for modem communication. So in early days, this RS-232 was used for modem communication. So that is when these control signals came in handy. So we shall see what are these. So the RTS that we saw, RTS and CTS signals coordinate the communication between DT and DC. Okay, so this, as I told, DT is the initiator device and DC is the responding device in RS-232. So whenever DT has a data to send, so that is this one, this device, the device which initiates the communication has some data to send, it activates RTS, that is request to send. So it is requesting the other device that I want to send the data, so whether you are ready. So that is what it is requesting using RTS. And if DC, so the second device or the device which responds, if it is ready to accept the data, so once DT sends RTS signal and this DC is ready to accept the data, so it activates the CTS. It is clear to send. Okay, so that is what. So one device is asking whether the other device is ready to accept the data, and the other device says yes using CTS signal. So that is what is happening. The use of RTS and CTS. So then data terminal ready DTR is activated by DT. So DT is the one which initiates the communication when it is ready to accept data. So this is reverse happening here. So RTS was raised whenever DT was ready to send the data, but DTR, data terminal ready, is activated when DT is ready to accept the data. So it is reverse happening here. Okay. And the data set ready DSR is activated by DCE, so the second device, when it is ready for establishing a communication link. So before you send the data, a link has to be established. Okay, so that is to establish that link, DC activates dataset ready signal. So once this DSR is raised, DTR should be activated state before activation of DSR. Okay, so that is the use of DTR and DSR. Okay, so the reverse of whatever is happening here. Next is data carrier detect. So it is used by DC. So DC is the responding device, not the initiating device, the responding device, to indicate the DT that a good signal is being received. Yeah, so once you establish a communication link, then it is necessary that that link is good enough so that the a better signal is being received. So that is detected by raising DCD signal. So next, the last one is ring indicator RI, so which is again used for modem specific signal line. So as I told, RS-232 in early days was used for modem communication. So that is where this RI was used. So whenever you use a modem with telephone, so the BSNL signals, BSNL connections, right? Those who use BSNL connections, they have to procure a landline. Okay? So as per EIA standards, so this RS-232 supports baud rates up to 20 kbps. This is the upper limit. Okay, 20 kbps. So this is a rough value, but the exact value is 19.2 kbps. So that is the maximum data rate. So the commonly used baud rates are, so this is maximum. So What is the other data rates within that maximum range? 300 bits per second. So this is kilobits, 19.2 kilobits. So this is bits per second, 1200 bits, 2400, 9600, 11.52 kilobits per second, and the maximum, which is 19.2. So these are the various baud rates or the speed of data communication available. So the maximum operating distance of this communication is 50 feet. So that is the maximum communication distance, and remember this is, what is this? This is wired communication, not wireless. Okay. So don't worry about this. That is sufficient. So to remember that much, it is sufficient. So the next external communication interface is USB, so Universal Serial Bus. So it is again wired high-speed serial bus for data communication. So it is wired and serial data communication. So USB system follows a star topology with USB host at the center and one or more USB peripheral devices connected to it. So this is, so there is a star topology followed in USB wherein there is a host. So remember, always in USB there should be a host, okay, and other peripheral or USB devices connected to it. So example I'll give, suppose there are two pen drives you want to, there are two pen drives and there is some data in those two pen drives, you want to exchange the data between those two pen drives. You cannot do that directly by connecting the first pen drive to the second pen drive. That is not possible, correct? So what you have to do, you have to connect those two pen drives, USB devices, to a laptop or a PC, correct? So the PC will act as a host so that you can do the transfer. So there should be always a host like a PC. That is what is the meaning of host and other device. So the host can connect up to 127 devices. Okay, so that is the maximum capacity of this star topology. So USB transmits data in packet form. So the data is not transmitted bitwise but in packet form. So data packet has a standard format. Okay, and the communication is always host initiated. It is host. So the USB is always host initiated, and the data is communication in terms of data packets. Okay, not individual bits. So USB host contains host controller. So there is a host controller in whatever the USB host. So responsible for controlling data communication. So host controls data communication, which includes establishing connectivity with the slave devices, then packetizing and formatting the data packets. So what do you mean by packetizing? See, let's say uh, there is a 64-bit data you want to send. So that 64-bit data first has to be organized in terms of packets of some size. Okay, so let's say the size is 16 bits. So each packet is of 16 bits. So then the 64-bit data is split into packets of 16 bits. So then it is 4 packets because it is 16 into 4, right? So 4 packets will be created and then it will format the data packet. So that is the responsibility of host, USB host. So there are different standards of USB host interface. So the two standards are open host control interface and universal host control interface. So just remember the names, that is sufficient. So there is uh, the syllabus doesn't cover in depth about these two. Just remember there are two interfaces. That's it. This is the diagram you can see here. So this is the host. So the star topology can have multiple hosts. Okay, so you can have two PCs connected with each other. So this is host and this is one more host, and these are the peripheral devices or the USB devices connected to it. So you can see there is no direct communication between two peripheral devices or two slave devices or USB devices. It has to go through so the communication has to go through the host like this only. Okay, so getting this, so that is what is the job of a host. So the physical connection between USB device and master device is established using USB cables. You are already familiar with USB cables and the types of USB cables. Okay, so there is a type A, there is type B, type C cable. Fine. So all the different types of cables are there that you are using already for mobile charging as well as data transfer. Yes, so USB supports a communication distance of 5 meters. That's all. So you can see only 5 meters is the maximum distance. So there are two types of connectors, type A and type B. So now there are various other types as well. Okay. So type A is used for upstream connection with host, and type B is used for downstream or connection with the slave device. So type B is used for connecting with the slave device. Yeah, so USB uses 4 pins because it is a 4 wire communication. So there is a V bus and a ground, which is carries 5 volts and a ground signal. Okay, so power signals. So other two are the data carrier signals. So differential carrier line D minus and differential carrier line D plus. So it just uh, works on the principle of differential, you can say, amplification concept. So each USB device contains a product ID and a vendor ID. So this is standard across all the USB devices anywhere in the world. Product ID is there, PID and vendor ID. So these two are embedded in the chip that comes within the device, USB chip. So the vendor ID supplied by is supplied with the USB standard for vendor ID. PID and VID are essential for loading drivers. So that is why these are used to identify the device, which type of device and what are the drivers required for that device. So you might have seen whenever you connect a new USB device to your laptop or PC, and if that PC is connected to internet, so it will try to download the drivers. So it will say installing the drivers, downloading drivers. So that is what is the use of PID and VID. So USB supports 4 types of data transfers. So it is just control, bulk, ISO, synchronous, and interrupt. So these are the 4 types of data transfers. So control transfer is used by USB system software to query, configure, and issue commands. So these are you can say the control transfer is used for establishing the communication. So that is what is used here for control transfer. Name itself indicates. So some control signals are being communicated. So next comes bulk transfer. So this is what majority of us use. So whenever you copy something to a USB or copy from the USB device, bulk transfer is for sending block of data to a device. So it supports error checking and correction as well. Okay. So example is data transfer to a printer. This is what the majority used type of communication. Okay. Or data transfer. Bulk transfer. So next the third one is isosynchronous data transfer. It is used for real-time data communication. So data is transmitted in streams in real time. So isosynchronous does not support error checking and retransmission. So there is no error checking or retransmission of data in isosynchronous. And when do you use isosynchronous? Whenever the data is with low or medium bandwidth transfer. Okay, so that is when you go for isosynchronous mode. You can see I have highlighted that here. And the last one is interrupt transfer. It is used for transferring small amount of data, very small amount of data. So this is used when this makes use of polling technique. You can see polling technique. Polling means you suppose there are 10 lines, so you'll not keep all the 10 lines active. So what you'll do is in a cyclic manner you will go on checking one after the other. Out of the 10 lines you will check one line after the other. First, let's say you check the line number 1. If there is some data to transfer, you will transfer the data. So then you'll go to line 2. So as soon as you go to line 2, line 1 and so other lines are not activated. Only line 2 is activated, and if there is some data to transfer, it will be transferred. So like that, all the lines will be checked serially, one after the other. But the line which is being checked is only active, the others are inactive. So that is what is polling. Okay. So this is the interrupt transfer mode wherein polling is used, and example is, so whenever you use mouse and keyboard, USB mouse and keyboard, so they will utilize this interrupt transfer mode of data transfer. Okay. So the frequency you can see varies from 1 to 255 milliseconds. So every 255 milliseconds the line will be checked. So that is what is polling. Okay, so this is about USB external communication interface. So next is IEEE 1394. Okay, so it is a standard which is also known as fireware. So there are multiple you can say vendors of this IEEE 1394. What is this? So it is again wired isosynchronous high speed data serial communication. High speed serial communication. Again it is serial only, wired only, but isosynchronous. So isosynchronous means it will make use of both synchronous and asynchronous data transfers. That is what you mean by isosynchronous. It is also known as high performance serial bus (HPSP). It was first added with Apple, started by Apple in 1985, and then the name was coined by IEEE, which is the organization for electrical and electronics engineers. Okay. So the Apple's implementation of 1394 protocol is known as fireware. So same implementation by Sony is known as links. Okay. Sorry, iLink for Sony and links for Texas. So there are various names depending on which is the company that is trying to implement it. Okay. So don't worry, just remember it as IEEE 1394 or fireware. So next it supports peer-to-peer connection and point-to-multi-point connection. So peer-to-peer means point-to-point. So this is point-to-point. So that is from one device to another device. So next point-to-multi-point means one device to many devices, more than one device. So that is what. Okay. So but USB you saw it is point-to-point. Okay. So this is point-to-point as well as point-to-multi-point, and it totally allows 63 devices to be connected again in tree topology. So you just saw the tree topology in USB. So same will hold true here also. So it supports data rate from 400 to 3200 megabits per second. So Mbps. This is Mbps, right? Previously in USB we saw so no USB the data rate was not given, but you know that in USB 2 and in USB 3, so we can go up to 20 to 30 Mbps. So now you can see this one IEEE 1394. It is 400 to 3200 Mbps, okay, which is very high compared to USB. So it uses differential data transfer similar to USB. It uses differential data transfer again, and interface cable support three types, and this cable support three types of connectors: 4-pin, 6-pin, and 9-pin. So there are three types of connectors. So again, if it is 4-pin, the connector is called 4-pin. Similarly, 6-pin, so the connector is called 6-pin. So these are the pins for 4-pin, 6-pin, and 8-pin, 9-pin connectors. Okay. So just remember the names. That's all. So differential signal for line, signal line B, for signal line B. Okay. So there are multiple signal lines here. Yeah, so what is the difference here? Unlike USB interface, except USB OTG, so IEEE 1394 doesn't require a host. Okay, so as I told in USB, the USB required a host. I gave an example of PC, right? So and two pen drives. But here there is no necessity of host. So two devices can directly communicate with each other. So that is what is the example. The example given is scanner can be directly connected to a printer. So in early days, so now there are multifunction printers wherein scanner comes with the printer. But in early days they came separately. So there are separate scanner device and a separate printer device. So they both can be directly connected without needing a PC. Without needing a PC for host. Okay. Yeah. So this is popular communication interface for connecting embedded devices like digital camera, camcorder, scanners with desktop computers. Okay. So this is about IEEE 1394. So all till now whatever the interfaces we discuss, okay, so which is on board or off board, all were wired only. So now we'll move on to wireless communication interfaces. So external communication interface, infrared, IRDA. So the most common use of this is in your remote, TV remote, AC remotes, whatever the remote application. So that is the typical use of IRDA. So apart from that, there are other uses also. What is this? So it is again serial, half duplex, line of sight. So this is very important. It is serial, half duplex. Half duplex means uh, one-way communication is possible at any given point of time. So no two-way communication simultaneously. Fine. And it is line of sight. So what do you mean by line of sight? So the other device that you want to communicate with should be visible to the first device. So the first device should be visible to the second device, and the second device should be visible to the first device. So that is what is line of sight. So if the devices are not visible to each other physically, they are not visible to each other. So the communication is not possible. That is what is line of sight. Okay. Yeah. So this technique makes use of IR rays, that is infrared waves, so in the electromagnetic spectrum for data transmission. So these IR waves are not visible to human eyes. Okay, so the wavelength is not visible to the human eyes. So this supports point to point and point to multi-point again. Okay, so provided all devices involved are within the line of sight. So as I told, they should be visible to each other. So typical communication range is 10 centimeter to 1 meter. That's also very limited range. Fine. So you might have experienced this whenever you use the remote, right? So you cannot go beyond a certain range, so because that remote key press will not be detected by the TV or the music system. So IR supports data rates ranging from, what is the data rate, 9600 bits to 16 Mbps. So the rate is less compared to the firewire that we discussed previously. So depending on the speed of data transmission, so depending on the speed, the IR is classified into serial IR, medium IR, fast IR, very fast IR, and ultra fast IR. So this is the classification based on speed. So there are totally 5 types of transmissions. Okay. So next, IRDA communication involves a transmitter unit for transmitting the data and a receiver. So there is a transmitter and a receiver. So in transmitter there will be a infrared LED. So you might have seen this in the remote. There is a LED in the beginning or the top of the remote, which will send the you can say data to the receiver which is present in the TV or music system. So but whenever you press that, so whatever the data that is sent, the LED, you cannot see the light, right, because it is not visible. And at the receiver, what will be there? There will be a photodiode. So there will be a receiver, and in that there is a photodiode which is sensitive to IR wavelength. Okay, so this is what is IRDA, wireless communication, half duplex. Okay, half duplex. So next one is Bluetooth. So very famous with uh, all the mobile devices, right? Very famous. So what is this? Low cost, low power, short range wireless technology for both data and voice. So it gives data as well as voice. Fine. So again, it says short range. So the range is about maximum is 10 meters. That's all. Bluetooth operates. So what is the operating frequency? 2.4 gigahertz. So many know this already. So it uses RF frequency, and in RF the technique that it uses is data transmission technique is frequency hopping spread spectrum, FHSS. So you might have already studied this in the communication theory, right? So next, Bluetooth is theoretically a maximum data rate of up to 1 Mbps. So very less, you can say that 1 Mbps, and range is 30 feet, which is nothing but 10 meters. That is what I told. So Bluetooth communication has two essential parts. So what are the two essential parts? The physical part, and next is the protocol part. Protocol. Okay, so what do you mean by protocol? So protocol is nothing but a set of rules which governs the transmission, because any given data transmission has to have a certain set of rules. Without those rules, the transmission will not be proper. Okay, so there should be some rules. So it is just like the rules that you use for speaking a language. Okay, if you don't use the rules to speak that language, so the other person might not understand that language, right? So that is nothing but a protocol. So there are two parts: physical link and protocol part. So physical link, as the name itself indicates, is responsible for data transmission, and protocol part is responsible for defining the rules, as I told, set of rules, right? So the physical link works on wireless principle, since it is wireless communication, so which is RF based, and it is frequency is 2.4 gigahertz. So every Bluetooth enabled device contains a Bluetooth wireless radio. What do you mean by radio? It is nothing but a antenna. Okay, so there should be an antenna. Every Bluetooth device will have a antenna which supports 2.4 gigahertz, right, for transmission and reception of data. So the rules governing the Bluetooth communication is implemented by Bluetooth protocol stack. So where these rules are available in the IC. So every device will have a IC, Bluetooth device. So in that device the rules will be saved. So each Bluetooth device will have a 48-bit unique identification number. So it is nothing but the, you can say, an address given to every Bluetooth device which supports Bluetooth. So Bluetooth communication follows again packet based. So it is just like the USB, which again follows packet based data transfer, right? So that we are already studied. So Bluetooth supports again point to point and point to multi-point. Okay, so both it supports wireless. So point to point follows master slave relationship. So if it is from one device to another device, it is master slave relationship. Okay, so a Bluetooth device is capable of functioning as a master as well as a slave. Both is possible. Yeah, so this is about Bluetooth. So now we shall move on to one more wireless communication technology which is famous, which is Wi-Fi, wireless fidelity. So it is technique used for networked communication. So networked means whenever there are more than, let's say, 3 or 4 devices which should be connected with each other. So that is when the network comes in. So example is your LAN, okay, wired LAN. So that is a network communication. So Wi-Fi follows a standard which is IEEE. Again, it is coined by IEEE. So the standard number is 802.11. Wi-Fi is intended for network communication, and it supports internet protocol IP based communication. So that is, every device connected to a network will have a IP address. Okay, you might have seen the address in the system. So it is 102.0.1 like that. So that is the IP address. So Wi-Fi based communication require any intermediate agent called, so it is the agent called Wi-Fi router. So as soon as you see hear Wi-Fi, so there should be a router. Okay, so it is just like a host, can say. So there should be a router, which is nothing but a wireless access point to manage the communication. So using this router, you can block the access or do some restricting access to the network. So suppose you don't want a particular device to access the network, you can block the device from accessing the network using this router. Okay, you can use the IP address of that device that you want to block, and using the router you can block the device, right? And routing data packets. So again, this packet based uh, transmission, and this everything is taken care by the router. So it is responsible for restricting the access to network, assigning IP address to every device, as well as routing the data packets. So send and receive the data. So again, these Wi-Fi enabled devices will have a what is that, antenna. Again, there should be an antenna or a radio which supports the frequencies 2.4 or 5. So there are two operating frequencies for Wi-Fi: 2.4 gigahertz and 5 gigahertz. So and you can see the frequency is same for Bluetooth as well. Okay, but the set of protocols are different. So Wi-Fi is A Wi-Fi network is identified by SSID. So what is SSID? Is nothing but the name of the Wi-Fi network. So whenever you create a hotspot in your mobile, okay, so you can change the name that you give. So you will give like Redmi Note 6 or let's say OnePlus 7. That is the network name. So you can some even give their name also for the network for the hotspot that they create, right? So that is what is SSID. So then a Wi-Fi device can connect to a network. So by selecting the SSID. So suppose you want to connect to a network, let's say GMIT is the network, that is the SSID GMIT. So you want to connect it to it. So you turn on your Wi-Fi and select GMIT. So as soon as you select GMIT, it will ask you to enter the credentials. So it is the password for that network. So without the password, you cannot connect to the wireless network. Okay. So there are various mechanisms to implement this credentials, okay, or passwords or security. So the methods are, first method is WEP, wireless equivalency protocol. So this is rarely used nowadays, but what is used is WPA, wireless protected access. So this is available in mobile also. So if you go to your hotspot settings, there you can select this WPA1 or WPA2. So wireless protected access, right? This is about Wi-Fi. So next we'll move on to one more wireless technology, communication interface, which is Zigbee. So again it is wireless. So again it is low power, low cost wireless network communication. So Wi-Fi is not low power, low cost, but this is low power, low cost. So based on some again a standard is given 802.15.4-2006. So this is targeted for low power, low data rate and secure applications. So it is low power, low data rate. So whenever the data rate is not much, you go for Zigbee. Okay. So if the data rate is more, you can go for Wi-Fi. So and it is used for personal area network, wireless personal area network. So in this there will be a mesh. Okay. So mesh means the devices are interconnected with each other, and whatever the data you want to send, it will go through every device. So what is the meaning of that is I'll show the diagram here. So can you see the diagram here? So now suppose you want to send the data from ZED to ZED, this one, it has to go to this ZC and then it will go to ZED. So that is what you mean by mesh. Every device is connected with the host. So there are multiple nodes. So this is more reliable by pertaining messages to travel through a number of different paths to get from one node to another. So that is what I told. So what is the operating frequencies? The multiple operating frequencies, but they are unlicensed because it is personal area network, not a standard network. So 2.4 to 2.4.84, 902 to 928 megahertz, like this. So it supports a distance of 100 meters. Okay. And the data rate is 20 to 250 kbps. That's all. You can see it is 20 to 250 kbps, not mbps. So it is, as I told, for low data applications, low power, low data applications. What are the applications? So home automation and industrial automation. Okay. So energy management, home control security, some patient tracking. Okay. So then logistics. Logistics means your courier services, right? And then sensor networks. So these are typical examples. You can see all are local applications. So and automatic AMR, automatic meter reading, smoke detection, wireless telemetry, and HVAC. So what do you mean by HVAC? Heating, ventilation, and AC control. So this is implemented in large apartments, or you can say large shopping malls, okay, large buildings. So there the Zigbee is used to communicate with the sensors and the devices. So you can see this is the typical connection diagram of Zigbee. So there are two types of devices here. One is ZC. So what is ZC? It is known as Zigbee coordinator. So it acts as a root or a host, as I told. It is a host. It is responsible for initiating the network and It has capability to store the information about the network. So information about the network may be how many devices are there, how many ZCs are there, how many ZRs are there, how many ZEDs are there. So that is what is the information. This is ZC. So it is just like a host. So then next is ZR, which is Zigbee router. So similar to a Wi-Fi router, it is Zigbee router. So it is responsible for passing information from device to another device or to another ZR. Okay. So a ZC will also act as a ZR, but a ZR cannot act as a ZC. Just remember this. So next comes the ZED. So it is Zigbee end device ZED. So what is this? End device containing Zigbee functionality for data communication. It can only talk with ZR or ZC, and it doesn't have the capability to act as a mediator. So it cannot act as a router. So ZEDs cannot be a router. It is nothing but the end devices. That's all. So this is about Zigbee. So next wireless communication is Gprs, General Packet Radio Service. So it is already, can say, old. So nowadays it is already 4G and 5G people are talking about. So it is based on GSM, mobile communication for data communications. So data is sent in packets again, similar to USB. So the entire data will be split into several related packets, and they will be sent individually, and once they are received at the receiving end, the data is reconstructed by combining the received data packets. So the data packets can be received in any order, but they have to be recombined properly to get the message. Okay. So the maximum speed is 171.2 Kbps. That's all. So that is what it is. You can see this is nothing but 2G. That's all. Gprs radio channel is concurrently shared between several users instead of dedicating a radio channel to cell phone users. What do you mean by this is, so only one radio channel will be there. That radio channel will be shared with many users. So example is it is just like a multiplexing. Okay, time multiplexing. So wherein same channel is shared between 4 or 8 different users. So wherein each user will be given a time slot. So within that time slot, the user will send the data, but the communication channel is only one. So it is just like a multiplexer. Okay. So what does a multiplexer do? So there are four, let's say it is 4:1 multiplexer. There are four inputs and only one output. So that one output will be shared by all the four inputs based on the select line. Correct. So based on this value of the select line, or the which input will be communicated to the output is selected. So similarly here it is time multiplexed. Okay. So every channel will be given a, or every user will be given a time slot within which he has to transmit the data. So next, Gprs supports IP again, similar to Wi-Fi. It supports IP, so it supports point-to-point protocol. Okay, so, and it is used by mobile-enabled embedded devices. So this was a very popular means of communication in early days, but not now. Okay, so Gprs hardware uses Gprs modem. So a modem is required here. Okay, and a Gprs radio. Radio is, as I told, it's an antenna. So every mobile is having an antenna, right? So that is what. So then Gprs is old technology, as I told. It is being replaced by new generation technologies like Edge, HSDPA, so which is close to 3G, and now it is 4G and 5G. So that is what. Fine. So this is about the external communication interface. Fine. So in which some are wired and some are wireless. Thank you.